So in the previous video, I talked about what makes up a geometric series and how do we know if it converges. And in another video, I talked about the proof for the sum of a geometric series. So, if you want to go back and see the proof of this formula, it's always a divided by 1 minus r. This is a formula worth memorizing, not just to find the sum of a geometric series, but to identify if a series that's been given to you is geometric or could be written easily as a geometric series. A is the first term, r is the common ratio. So the first thing I guess I usually like to do is get my series written in a nice way, which means I would like to see it, there might be some kind of constant term, but I'd like to just see it as a to the n, or I'm sorry, some number to the nth power. So I think I'll rewrite this, and in the interest of time and also maybe my handwriting, if you'll forgive me, I'm not going to write the n, well, I suppose I better. Let me take that back. I'll write the n equals 0 and infinity. So I like to have it written in the nice form that we normally see a geometric series. And then I say, okay, well, what is the first term? Well, you'll notice it tells me to start at 0, so let's start at 0. If I plug 0 in, 4 times 1/3 of the 0 is 4. So that's my first term. Common ratio is just whatever I'm multiplying by, so 1/3. So the sum is the first term over 1 minus 1/3. So it's 4 over 2/3, which dividing by 2/3 is the same as multiplying by 3/2, so I could multiply by 3/2. So the answer is 6. That's the sum of that geometric series. So if it were possible to add up an infinite number of terms, I would get 6. So if I just kept adding more and more terms to this series, I just kept going out further and further, I would get closer and closer to 6, but never reach it. Okay? This next one, it's written in the nice form already that it's negative 1/3 to the n, so I don't have to do much algebra up front. Let me get my first term. So I start by plugging in 0. So anything to the 0 power is 1. So the first term is just 1. Common ratio is negative 1/3 because this is an alternating series, right? It's going to go positive term, negative term, positive term, negative term. So I have 1 over 1 minus negative 1/3, which is 1 over 4/3, which is 3/4. And that's the sum of that series. So in this last example, again, and I know we've worked with this one before, so let me get it rewritten in the form that we had gotten it so it looked nice and geometric like that. So starting again at 0, and you always want to pay attention to make sure it is starting at 0. 2 times anything to the 0, so the first term is 2. Common ratio is 2/5. So 2 over 1 minus 2/5 is 2 over 3/5, which is the same as multiplying by 5/3. So kind of run out of room, I'll put the answer up here. It's 10/3. So nice formula to use, and again, one that you should really keep in mind. It's first term over 1 minus common ratio. Okay, let's look at a couple more examples. So in this case, I'm not giving you necessarily the series written with sigma notation. I'm giving you some terms. So you have to look at it and say, well, what am I multiplying by every time? Well, of course, easy to pick out here. You're multiplying by 1/2, and you can see it, the general term written right there. Okay. So the first term was 1. The common ratio is 1/2. So 1 over 1 minus 1/2 is the same as 1 over 1/2, which is 2. That's the sum. Now, I just want you to think about this for a second because we don't maybe spend enough time thinking about partial sums. 1 plus 1/2 is 1.5. Then you add another, you got 1.75. Okay, the next term would be 1/8, and you'd have 1.875. The next term would be 1/16, which would be 1.9375. Next term would be 1/32, and you'd have 1.96875, and so on. So you just keep adding these smaller and smaller numbers, and it will approach 2. So 2 is almost like a limit. Right, it's the limit of what this series will be, but because it's a sum, we call it the sum of the infinite series. Okay, this next example, we've got 1 minus 1/3. So what we're multiplying by is negative 1/3. So first term was 1, common ratio was negative 1/3. So the sum would be 1 over 1 minus negative 1/3, which is 1 over 4/3, which is 3/4. Now again, just think about some terms here. Okay, 1 minus 1/3, this would be 2/3 if you actually went that far. Then if you added another term on, you added 1/9, you're at you're at 7/9. Okay, then the next term, of course, would be negative 1/27. Now you're at 20/27. So and that's 0.74. Now what's different about alternating, and I always like to kind of draw a picture like this, is picture you're going to plot these sums. Okay, picture you could plot these sums. So at the very first, at the beginning, you're at 1. So let's just say that's 1. Then you subtract 1/3, so then you're here. This is, the second term out, we'll say, is, you've added 2 sums, or 2 numbers. Then you go back up to 0.7 repeating, so that's the next sum and the next sum. So what's going to happen in this alternating is it's just going to keep going like that and getting closer and closer to 3/4 in the middle. So that's what happens with an alternating, is instead of like this one where it just kept getting bigger and bigger, but it would get closer and closer to 2, this one actually bounces back and forth over and under 3/4, but it'll keep getting closer because it's alternating. Lastly, I want to show you 2 multiple choice questions off some old AP exams. The reason I want to show you this is it doesn't necessarily on first glance look like it's a geometric series. In fact, there's a term in here you don't even know. The first thing is it says a Maclaurin series is given by that. We haven't talked about a Maclaurin series yet. But it says that the function f of x is given by this, negative x over 4. And that says, what's the value of f of 3? Well, let's just write down f of 3. F of 3 is equal to this, right? Just replacing 3 or x with 3. Well, now it's a geometric series. Its first term, if you start with n equals 0, so the first term would be 1, and the common ratio is negative 3/4. So you got 1 over 1 minus negative 3/4, which is 1 over 7/4, which is 4/7. Now, this is a question that a lot of people get wrong. It's actually pretty, it's pretty easy to see once you substitute 3. But what throws people is says, well, what's the value? It doesn't say the sum. Right, but it's saying that f of x is equal to the entire series from 0 to infinity. So when it says what's the value, you're saying, well, I want the actual sum. I want to know when I go from 0 to infinity, what am I going to get as an answer? And the answer, of course, is the sum of the entire series. Now the next one is a little more straightforward. It says, what's the value of that? Well, I always like to have my series written in that very special form where it looks like this. You know, it may be a number, but then it's just something to the nth. Okay, so I'm going to take a -3 out of this. I'm going to write this as -3 to the n times -3 over 5 to the n, which means I can rewrite the whole series. Notice this one starts at 1 as -3 times -3/5 to the n. So the first term, well, if I plug in 1, I get -3 times -3/5 to the first. That's 9/5. The common ratio is -3/5. So I've got the first term over 1 minus the common ratio. So 9/5, kind of running out of room here, 9/5 divided by 8/5, which is 9/8. Okay, if you do the algebra. So again, look for these things. When it says what's the value, it's really saying find the sum. Now the beauty of this is there really aren't many series we can find the sums of. So if it says what's the value and it gives you a series, an infinite series, you almost know it's geometric and you just do the algebra to get it to what you want so you can work with it. Memorize that formula, a over 1 minus r.